Revolutionizing research: how DeepSeek R1 is transforming AI accessibility for 5 key scientific fields. Date: January 25, 2025. Time: 2025 to 2034. Summary: DeepSeek R1 has emerged as a revolutionary open-source AI model transforming access to advanced reasoning capabilities across 5 key scientific fields: education, software development, mathematical problem-solving, scientific research, and business analytics. With an impressive 671 billion parameters, DeepSeek R1 rivals proprietary systems like OpenAI's O1 and Google's Gemini 2.0, often exceeding their performance, especially in reasoning-intensive tasks. Key developments and achievements. 1. Performance benchmarks. DeepSeek R1 achieved a remarkable 79.8% pass rate on the AIME 2024 and a 97.3% accuracy on the Math 500, outshining OpenAI's O1, which scored 79.2% and 96.4% respectively. For coding tasks, DeepSeek R1 scored 96.3% on the Codeforce's benchmark, closely trailing O1's 96.6%. 2. Innovative training methodology. The model's success stems from its dual training approach, starting with a base model DeepSeek R1-0 trained through reinforcement learning RL without supervised fine-tuning, followed by cold start fine-tuning. This methodology fosters emergent reasoning behaviors such as self-reflection and chain-of-thought reasoning, which are essential for complex problem-solving. 3. Open-source accessibility. Released under an MIT license, DeepSeek R1 allows free modification and commercial use, significantly lowering barriers for researchers and developers. This open-source nature encourages collaboration and innovation, enabling smaller organizations to leverage high-performance AI without the prohibitive costs associated with proprietary models. 4. Use cases. Education functions as a virtual tutor, solving complex STEM problems and adapting to individual learning styles. Software development aids developers through code generation, debugging, and optimizing algorithms, supporting 338 programming languages. Scientific research analyzes data, generates hypotheses, and assists in writing research papers, enhancing productivity. Business analytics processes large datasets to offer strategic insights for decision-making. Comparative analysis. DeepSeek versus OpenAI. While OpenAI excels in conversational tasks and general-purpose applications, DeepSeek R1's specialization in reasoning and cost efficiency makes it a compelling alternative for academic and research institutions. DeepSeek versus Gemini 2.0. Although Gemini 2.0 leads in multimodal reasoning, DeepSeek R1's focus on text-based tasks, particularly in education and coding, provides a specialized edge. Challenges and future directions. Despite its successes, DeepSeek faces challenges such as limited multimodal capabilities, language mixing in outputs, and the computational demands of large models. Future efforts will focus on expanding multilingual support, enhancing multimodal reasoning, and optimizing enterprise applications through dedicated APIs and SaaS solutions. Timeline of developments. January 2025, DeepSeek R1 is highlighted in various publications for its groundbreaking performance in reasoning tasks and open-source accessibility. Performance benchmarks. Throughout early 2025, comparisons with OpenAI and Gemini models established DeepSeek R1 as a formidable competitor in the AI landscape. Conclusion. DeepSeek R1 signifies a major advancement in AI, democratizing access to high-performance reasoning tools while fostering innovation across multiple fields. Its open-source model not only enhances research capabilities but also ensures that cutting-edge AI technologies are accessible to a broader audience, promoting collaboration and progress in the global AI community. In-depth analysis of DeepSeek R1's impact. 1. Introduction to DeepSeek R1. DeepSeek R1 has quickly established itself as a cutting-edge tool in the AI landscape, particularly in reasoning-intensive tasks. The model was developed by a dedicated team at DeepSeek AI, a research lab based in China committed to making AI technologies accessible to the broader research community. Its open-source nature allows researchers and developers to modify and utilize the model freely, fostering an environment of collaboration and innovation. 2. Performance highlights. DeepSeek R1's performance on various benchmarks speaks volumes about its capabilities. For example, its performance on the AIME 2024 and Math 500 benchmarks showcases its prowess in mathematical reasoning, outperforming established models like OpenAI's R1. Such results highlight the potential of DeepSeek R1 in educational settings where precise mathematical problem-solving is crucial. Performance benchmarks overview. AIME 2024, 79.8% pass rate. Math 500, 97.3% accuracy. Codeforce's benchmark, 96.3% accuracy in coding tasks. These benchmarks not only demonstrate the model's capacity for advanced reasoning but also its applicability in real-world scenarios. 3. Training methodology. DeepSeek R1's innovative training methodology is a key contributor to its success. The model employs a two-phase training process. Phase 1, initial training with DeepSeek R1-0 through reinforcement learning without supervised fine-tuning, allowing the model to develop reasoning capabilities autonomously. Phase 2, cold start fine-tuning, which stabilizes and enhances the model's outputs by incorporating high-quality datasets. This training approach ensures that DeepSeek R1 exhibits emergent reasoning behaviors, such as the ability to self-correct and engage in complex logical reasoning. 4. Open-source accessibility. The open-source release of DeepSeek R1 under the MIT license has made it an appealing option for researchers and developers who may not have access to the resources required for proprietary models. This accessibility promotes innovation and collaboration, enabling a wide range of applications across various fields. 5. Real-world applications. DeepSeek R1's versatility is evident in its numerous applications, including education. By acting as a virtual tutor, DeepSeek R1 assists students in mastering complex STEM topics, adapting to their individual learning styles. Software development. The model's ability to generate and debug code across 338 programming languages supports developers in improving their workflows. Scientific research. DeepSeek R1's capability to analyze data and generate hypotheses aids researchers in their investigations, streamlining the research process. Business analytics. The model provides strategic insights by processing large datasets, facilitating informed decision-making in corporate environments. 6. Comparative analysis with competitors. DeepSeek R1 stands out in its competitive landscape, particularly against models like OpenAI's R1 and Google's Gemini 2.0. Strengths of DeepSeek R1. Specialization in reasoning tasks, particularly in STEM and coding. Cost efficiency, making it accessible to smaller organizations and academic institutions. Limitations compared to competitors. Gemini 2.0 strength in multimodal reasoning is a notable advantage, highlighting an area where DeepSeek may need to expand its capabilities. OpenAI's models excel in conversational tasks and broader applications, which could pose a challenge for DeepSeek in general-purpose markets. 7. Future directions and challenges. While DeepSeek R1 has achieved significant milestones, several challenges remain. Multimodal capabilities. The need to expand into visual reasoning and multimodal applications to compete with models like Gemini 2.0. Language mixing. Addressing issues of language consistency and outputs to enhance usability in multilingual contexts. Scalability. Ensuring that the model can be deployed efficiently in resource-constrained environments. Future development efforts will focus on overcoming these challenges while continuing to innovate in reasoning and problem-solving capabilities. 8. Conclusion. DeepSeek R1 represents a critical evolution in AI, providing powerful reasoning capabilities across various fields while promoting open-source accessibility. As the model continues to develop, it holds the potential to reshape the landscape of AI, making advanced technologies available to a broader audience and fostering collaboration and innovation. The future of DeepSeek R1 is bright, with opportunities for growth and expansion into new domains, ensuring its place as a leader in the next generation of AI research and application. DeepSeek R1 is revolutionizing the accessibility of advanced AI reasoning capabilities across multiple scientific fields, presenting profound implications for the future of AI research and application. Here I will highlight the counterintuitive aspects of DeepSeek R1 and its implications, particularly in the context of its competitive positioning against established AI models like OpenAI's O1 and Google's Gemini 2.0. 1. Open source versus proprietary models. While proprietary models like OpenAI's O1 and Gemini 2.0 have dominated the AI landscape, DeepSeek R1's success as an open-source model presents a counterintuitive challenge to this status quo. The democratization of AI through open source means that smaller organizations and researchers can access and modify high-performance models without the financial barriers typically associated with proprietary systems. This shift could lead to greater innovation and collaboration in AI development, a domain often perceived as being monopolized by a few large companies. 2. Performance metrics. It might seem logical that larger models with more parameters would always outperform smaller ones. However, DeepSeek R1, with its 671 billion parameters, demonstrates that innovative training methodologies can yield superior results even against highly optimized proprietary counterparts. For example, it achieved a 97.3% accuracy on the Math 500 benchmark, surpassing OpenAI's O1, which achieved 96.4%. This suggests that the approach to training and model architecture can be just as critical, if not more so, than sheer model size. 3. Cost efficiency. Conventional thinking might indicate that more advanced AI models would naturally come with higher training and operational costs. Yet DeepSeek R1 has proven to be significantly more cost-efficient, with training costs estimated at 90 to 95% lower than those of OpenAI's models. This counterintuitive finding suggests that high performance does not necessarily correlate with high expenditure, challenging the notion that only well-funded organizations can develop cutting-edge AI. 4. Multimodal capabilities versus specialization. Typically, models like Gemini 2.0, which incorporate multimodal reasoning capabilities, text, images, etc., are viewed as more advanced. However, DeepSeek R1's focus on specialized reasoning tasks, particularly in STEM and coding, allows it to excel in domains where precise logical reasoning is paramount. This specialization indicates that being highly focused on a particular area can yield better results than trying to balance multiple modalities, which may dilute performance in any single area. 5. Emergent behaviors from RL. DeepSeek R1's use of reinforcement learning (RL) as a primary training method leads to the emergence of advanced reasoning capabilities such as self-reflection and chain-of-thought reasoning. This goes against traditional beliefs that more structured, supervised learning is necessary for developing such complex cognitive behaviors. The ability of DeepSeek R1 to derive such capabilities from RL alone challenges the conventional wisdom surrounding model training. 6. Accessibility of high-performance AI. The assumption that advanced AI must be complex and costly to access is challenged by DeepSeek R1's open-source availability. The release of smaller distilled versions of the model allows broader access to high-performance AI, enabling users with limited computational resources to leverage advanced reasoning capabilities. This democratization of AI can lead to unexpected applications and innovations from unexpected sources, not just established tech giants. 7. Real-world applications and impact. The implications of DeepSeek R1 extend beyond technical metrics. Its applications in education, software development, scientific research, and business analytics highlight a shift in how AI can assist in complex problem-solving across various fields. This suggests that the integration of AI in real-world scenarios is not merely a technical challenge but one of societal and educational transformation. 8. Potential for global collaboration. The open-source nature of DeepSeek R1 fosters a collaborative environment for innovation. Contrary to the notion that competition leads to isolation in technology development, DeepSeek R1's model encourages partnerships and contributions from diverse communities, potentially leading to a richer development ecosystem. 9. Challenges of language and multimodal integration. While DeepSeek R1 excels in reasoning, it faces challenges with multimodal capabilities and language mixing in outputs. This presents a counterintuitive scenario where a model excelling in a specific domain may lag in versatility. Overcoming these challenges could lead to even more robust applications. But it also underscores the complexity of developing truly generalized AI systems. 10. Future of AI development. Finally, the rise of DeepSeek R1 signals a potential paradigm shift in AI development towards more accessible, specialized, and collaborative approaches. This counters the prevailing trend of relying on large corporations to drive innovation, suggesting a future where open-source models could dominate the landscape, driven by community collaboration and shared knowledge. In conclusion, DeepSeek R1 represents a significant shift in the AI landscape, challenging traditional beliefs about model performance, cost, accessibility, and the potential for global collaboration. As it continues to evolve, its implications may redefine how AI is developed and utilized across various fields, democratizing access to powerful reasoning tools while promoting innovation and collaboration. DeepSeek R1 presents a transformative paradigm in AI, particularly in reasoning capabilities across 5 key scientific domains: education, software development, mathematical problem-solving, scientific research, and business analytics. While the report provides a wealth of insights into DeepSeek R1's performance, methodology, and applications, certain significant aspects may be overlooked by readers. 1. Open-source accessibility. The open-source nature of DeepSeek R1, licensed under MIT, is one of its most critical features. This aspect may be underappreciated by those focused solely on performance metrics. Open-source models lower barriers for researchers and developers, allowing for broader experimentation, customization, and adaptation of AI technologies. This democratization of AI enables smaller organizations, academic institutions, and startups to leverage high-performance tools without the prohibitive costs associated with proprietary systems. Significance. The significance of this lies not only in immediate access to advanced tools but also in fostering an inclusive innovation ecosystem. Open-source platforms encourage collaboration, enabling researchers globally to share findings and advancements, which can lead to faster progress in AI development and application. 2. Innovative training methodology. DeepSeek R1's dual training approach, incorporating reinforcement learning (RL) without supervised fine-tuning followed by cold start fine-tuning, is a technical innovation that deserves deeper recognition. This method enables the model to develop emergent reasoning capabilities such as self-reflection and chain-of-thought reasoning. Significance. By utilizing RL, DeepSeek R1 can autonomously refine its problem-solving capabilities, which is crucial for complex reasoning tasks. This ability not only enhances the accuracy of outputs but also allows for dynamic learning, adapting to new information and contexts, which is vital in real-world applications. 3. Emergent reasoning behaviors. Emergent behaviors such as self-reflection and chain-of-thought reasoning are critical features that differentiate DeepSeek R1 from its competitors. These abilities enable the model to revisit and verify its reasoning steps, ensuring increased reliability in outputs, particularly for multi-step problems. Significance. The ability to engage in self-correction and generate coherent logical sequences of thought is essential for applications requiring high levels of accuracy such as scientific research and advanced mathematics. This capability might be overshadowed by performance benchmarks but is fundamental to the model's utility in real-world scenarios. 4. Performance benchmarks versus real-world applications. While the report highlights impressive performance metrics on benchmarks such as AIME 2024 and Math 500, the practical applications of these capabilities in real-world settings can be overlooked. For instance, in education, DeepSeek R1's ability to act as a virtual tutor can significantly enhance personalized learning experiences. Significance. The implications of these applications extend beyond mere performance statistics. By providing real-time assistance in education and software development, DeepSeek R1 can play a transformative role in skill development and knowledge acquisition. Addressing gaps in traditional educational methods. 5. Challenges in multimodal capabilities. DeepSeek R1's current limitations in multimodal reasoning, particularly its lack of integration with visual data, are crucial considerations that might not receive adequate attention. While the model excels in text-based tasks, the absence of multimodal capabilities could restrict its application in fields that require both textual and visual reasoning, such as healthcare and engineering. Significance. The challenge of integrating multimodal input is significant as industries increasingly demand systems that can process and reason across various types of information. Addressing this gap will be essential for DeepSeek to compete effectively with models like Google's Gemini 2.0, which already excels in multimodal applications. 6. Future directions and ethical considerations. The report outlines future directions for DeepSeek, including enhancing multilingual support and expanding its capabilities to include multimodal reasoning. However, the ethical implications of deploying such powerful AI models may not be fully explored. Significance. As AI systems become more integrated into societal functions, ethical considerations such as bias, fairness, and responsible use become paramount. DeepSeek has the opportunity to lead in establishing ethical standards for open-source AI, ensuring that advancements align with societal values and do not perpetuate existing biases. 7. Distillation for broader accessibility. The distillation of DeepSeek R1 into smaller models is another critical aspect that may be overlooked. This process allows for the deployment of AI capabilities in resource-constrained environments, making advanced AI tools accessible to a wider audience, including those with limited computational resources. Significance. This capability is particularly important for educational institutions and startups that may lack the infrastructure to utilize larger models. By providing distilled versions of DeepSeek R1, the organization can extend its reach and impact. Fostering innovation in less privileged settings. Conclusion. DeepSeek R1's innovations in AI accessibility, training methodology, emergent reasoning behaviors, and open-source principles are significant in shaping the future landscape of artificial intelligence. While performance benchmarks are crucial, the broader implications of DeepSeek R1's capabilities, its ethical considerations, and its potential to democratize advanced AI technology represent transformative opportunities that must be acknowledged and cultivated. As the AI field continues to evolve, the focus on these often overlooked aspects will be pivotal in driving responsible and inclusive innovation. 1. Performance and benchmarking. DeepSeek R1 has established itself as a formidable competitor in the AI landscape by achieving impressive results on key benchmarks such as the AIME 2024 and Math 500. With a 79.8% pass rate on the AIME 2024 and a 97.3% accuracy on the Math 500, DeepSeek R1 has outperformed OpenAI's O1 in mathematical reasoning tasks. This performance is critical as it showcases the model's advanced reasoning capabilities, particularly in STEM fields, which can have significant implications for educational tools and scientific research. 2. Innovative training methodology. The success of DeepSeek R1 can be attributed to its unique training approach, which involves a two-stage process combining reinforcement learning (RL) and cold start fine-tuning. Initially, the model DeepSeek R1-0 was trained purely through RL, allowing it to develop emergent reasoning capabilities without the constraints of supervised fine-tuning. This innovative methodology not only enhances the model's ability to tackle complex problems but also fosters behaviors such as self-reflection and chain-of-thought reasoning, setting it apart from traditional models that rely heavily on labeled datasets. 3. Open-source accessibility. One of the most revolutionary aspects of DeepSeek R1 is its open-source nature, released under an MIT license. This accessibility democratizes AI technology, allowing researchers, developers, and companies to freely modify and utilize the model for various applications. By significantly lowering the barriers to entry for high-performance AI, DeepSeek R1 encourages innovation and collaboration within the global AI community. This approach contrasts sharply with proprietary models like those from OpenAI, which often come with high costs and restrictions, thus enabling smaller organizations and academic institutions to leverage cutting-edge AI for their needs. 4. Diverse applications across fields. DeepSeek R1's versatility extends across multiple domains, including education, software development, scientific research, and business analytics. In education, it can function as a virtual tutor, providing detailed solutions to complex problems and adapting to individual learning styles. In software development, it supports code generation and debugging while also assisting researchers in data analysis and hypothesis generation. Furthermore, its capabilities in business analytics allow organizations to gain valuable insights from large datasets, demonstrating its potential to transform various industries by enhancing productivity and decision-making. 1. The OpenAI GPT-2 and GPT-3 revolution. The development and release of OpenAI's GPT-2 and GPT-3 models marked significant milestones in the accessibility and capabilities of natural language processing. GPT-2, which was released in 2019, showcased the potential of large language models (LLMs) by generating coherent and contextually relevant text across various topics. However, it was the subsequent release of GPT-3 in 2020 that truly revolutionized AI accessibility, boasting 175 billion parameters and enabling a wide range of applications from creative writing to coding assistance. OpenAI's efforts to democratize access to AI through the API allowed developers and researchers to leverage this technology, similar to the open-source approach of DeepSeek R1. 2. The rise of BERT bidirectional encoder representations from transformers, introduced by Google in 2018. BERT transformed the field of natural language understanding by enabling models to consider the context of a word based on its surrounding words. This bidirectional training allowed BERT to achieve state-of-the-art performance across various NLP benchmarks. Its release as an open-source model facilitated widespread adoption, leading to numerous adaptations and improvements by researchers and developers worldwide. Just as DeepSeek R1 democratizes advanced reasoning capabilities, BERT laid the groundwork for accessible language understanding technologies. 3. The impact of TensorFlow and PyTorch on AI development. The introduction of TensorFlow by Google in 2015 and PyTorch by Facebook in 2016 revolutionized the accessibility of deep learning frameworks. These open-source libraries provided researchers and developers with powerful tools to build, train, and deploy neural networks, significantly lowering the barriers to entry in AI development. The community-driven nature of these frameworks led to rapid advancements and innovations in AI research. Much like the collaborative potential fostered by DeepSeek R1's open-source model. As a result, countless applications across various domains emerged, showcasing the transformative power of accessible AI technologies. Future outlook: predictions for DeepSeek R1 and AI accessibility in scientific research. The advent of DeepSeek R1 marks a pivotal moment in the realm of artificial intelligence, particularly concerning its accessibility and application across various scientific fields. As we look towards the future, several predictions can be made regarding the evolution of DeepSeek R1 and its impact on AI accessibility in key scientific domains, including education, software development, mathematical problem-solving, scientific research, and business analytics. 1. Enhanced multimodal capabilities. Prediction: by 2027, DeepSeek R1 is expected to evolve into a multimodal AI model capable of integrating text, images, and possibly audio akin to Google's Gemini 2.0. This integration will allow for more sophisticated reasoning across diverse input types, expanding its utility in fields such as healthcare, where both textual and visual data like medical imaging are integral. Implications: such advancements will enable DeepSeek R1 to assist in complex tasks such as diagnosing medical conditions by analyzing both patient reports and imaging data, thus providing comprehensive support to healthcare professionals. 2. Democratization of AI in education. Prediction: by 2026, DeepSeek R1 will significantly impact educational technology with a projected increase in its use as an AI tutor across schools and universities globally. Its open-source nature will facilitate the development of tailored educational applications that adapt to individual learning styles, enhancing personalized education. Implications: this could lead to a more equitable education landscape where students from diverse backgrounds gain access to high-quality AI-driven tutoring, fostering a generation of learners equipped with advanced problem-solving skills, particularly in STEM fields. 3. Expansion of language support. Prediction: by 2028, DeepSeek R1 will incorporate extensive multilingual capabilities, supporting a wide range of languages with improved reasoning accuracy. This expansion will be crucial in regions with underrepresented languages, making advanced AI accessible to a broader audience. Implications: this will not only enhance global communication but also empower researchers and developers in non-English speaking countries to leverage AI tools, thereby bridging the digital divide in access to cutting-edge technology. 4. Increased collaboration and open-source contributions. Prediction: by 2025, the open-source community around DeepSeek R1 will flourish, resulting in an increase in collaborative projects and innovations that push the boundaries of AI research. This collaborative environment will see contributions from universities, startups, and individual developers, leading to a rich ecosystem of applications and enhancements. Implications: such collaborations will accelerate the pace of AI advancements, leading to the rapid development of new features and models that can address specific challenges faced in various scientific fields. 5. Ethical AI development and governance. Prediction: over the next 5 years, DeepSeek will prioritize establishing ethical guidelines and governance frameworks for the responsible deployment of its models. This will involve community-led initiatives focused on bias detection, transparency, and accountability in AI applications. Implications: as ethical considerations become increasingly important in AI development, DeepSeek's commitment to responsible AI will enhance its credibility and trustworthiness, making it a preferred choice for organizations concerned about ethical implications. 6. Integration into business analytics. Prediction: by 2026, DeepSeek R1 will become a standard tool in business analytics, enabling organizations to process large datasets and generate insights through advanced reasoning capabilities. Its ability to analyze complex data will help businesses make informed decisions quickly. Implications: this will not only improve operational efficiency but also provide smaller organizations with access to high-performance analytics tools that were previously only available to larger enterprises with significant resources. 7. Advancements in research productivity. Prediction: by 2027, DeepSeek R1 is expected to significantly enhance research productivity across scientific disciplines. With capabilities to analyze data, generate hypotheses, and assist in writing research papers, it will serve as a valuable collaborator for researchers. Implications: as a result, the pace of scientific discovery could accelerate, leading to more rapid advancements in fields such as medicine, environmental science, and technology, ultimately benefiting society at large. 8. Ongoing performance improvements. Prediction: continuous iterations and updates to DeepSeek R1 will result in ongoing performance improvements, with benchmarks consistently surpassing those of proprietary models like OpenAI's O1. By 2026, it is anticipated that DeepSeek R1 will lead in key reasoning benchmarks, solidifying its reputation as a top-tier AI model. Implications: this competitive edge will encourage more organizations to adopt DeepSeek R1 for their AI needs, further establishing it as a critical tool in both academic and commercial contexts. Conclusion: the future of DeepSeek R1 and its transformative role in AI accessibility for scientific fields appears promising. With advancements in multimodal capabilities, enhanced language support, and a commitment to ethical AI practices, DeepSeek R1 is set to democratize access to advanced reasoning tools. As it fosters collaboration within the open-source community and enhances productivity across various domains, DeepSeek R1 will likely emerge as a cornerstone in the ongoing evolution of artificial intelligence, shaping the future of research, education, and industry. The next few years will be crucial in determining how effectively DeepSeek can leverage its strengths to meet the growing demands and challenges of the digital age.